Well, thank you for that. And what we're going to talk about is a couple of things. First, of course, we are going to talk about how these glasses should not break the internet. But then we're going to shift gears and talk about how AI and networking infrastructure is helping nature fresh farms. And it's actually a fascinating story. So let's just dive right in. My name is Sanjay Uppal. I run the VeloCloud division at Broadcom. And our division makes infrastructure for networking that helps applications, and now, of course, Gen AI applications run much better on the internet. Just want to make sure this clicker. Okay, so the first point that we want to make is that since the time that we have started working in AI, which is both machine learning and Gen AI, AI we are finding across all verticals is becoming really ubiquitous. So in particular today, we're going to look at AI in food and agriculture, but across all of these verticals, there are applications that need to run on infrastructure that is global and that is distributed. So AI in transportation, food and manufacturing. So the first point to note is that AI is in fact distributed. By distributed, we mean it's not located just in your data center, it's globally distributed because you could have locations where you're running manufacturing or retail or your customers are coming in and you have to serve those locations as well. Therefore, AI is actually everywhere. Now, shifting gears into what's really happening in the AI infrastructure that's being run, you're of course very familiar with the large language model where someone would come in and say, how is this pot of chili to be made? And then a recipe is thrown back by a large language model that exists in some cloud location somewhere. But when we look at this next generation of AI, which is being talked about at this AI summit, AI is agentic. And that agentic AI means that there's the question that you ask, whether you're a human being or you're a thing, that question that you ask is then broken down into a number of sub-questions which are handled off into experts, and these experts are agents. The agents have agency, meaning that they can act on your behalf, and these agents tend to be distributed. So they are in different physical locations. And when they are in different physical locations and they need to interact with one another, that means networking comes into place. And that networking is what we build to make sure that distributed applications run well, and in particular, this new class of applications that are agentic or AI-based. So these agentic interactions that happen, you give an example of a shopper walking into a store, that shopper is recognized, and that shopper is wearing one of these glasses. These are the Ray-Ban Meta glasses that I'm wearing. These glasses can live stream video. They can also take pictures, like I can stand here, and if I click this button, then I've taken a picture of all of you. I can also say, hey, Meta, take a picture or take a video. And so this upstream traffic that is being sent is then handled by a large language model. In this case, happens to be Meta, but there's a whole slew of other smart glasses that are becoming available. And then an answer is given to the person or even the thing that is wearing these glasses. Now, the difference between what's happening today with the chatbot interactions that all of us do and what these glasses represent is two things. One is that agents are coming in to have this response based on agency, and the other is that the nature of traffic from these glasses is very different from what the traffic has been before, and that's really what I want to talk about quickly. A few things, this traffic is highly asymmetric, meaning that in today's interactions that you have with applications, there's a lot more download. When you watch Netflix, you say what Netflix movie you want to watch, but a lot more traffic comes download. In these glasses, it's exactly the opposite. When you're live streaming, 100-to-1 traffic is going in the upstream direction versus the downstream direction. Now, if you take this and you multiply it by all the glasses that Ray-Ban wants to sell, you can actually break the internet unless you come in and put in a network infrastructure that is capable of handling this much higher upstream traffic than there is downstream traffic. And that's the network for Gen AI that we are going about building. Now, there's other issues about latency and burstiness and the high bandwidth requirements as well. But the fundamental difference is that today's traffic that is web-based and smartphone-based is completely different from the Gen AI traffic that we're seeing that is agent-based and that is much more upstream than there is downstream. So we're asking the question, out of all the folks who are putting in Gen AI projects for FY25 and beyond, are you ready? Are you ready? Because when SaaS-based applications came in, like Microsoft Office 365, the network was not ready, and a whole new wave of network infrastructure had to be put in so that these applications could be run. A very similar thing is happening right now. As these applications are coming in, both agentic and not, the network is not really ready. So we're saying that for the network to be ready, you have to upgrade your network infrastructure to be able to support this kind of traffic. So we're introducing here a concept called Velo RAIN. This is an architecture, not a product. The RAIN stands for Robust AI Networking. And Velo is, we're part of the Velo Cloud division at Broadcom. So we've named this as Velo RAIN. And what Velo RAIN essentially does is that when you have these glasses on, it recognizes the application that you're running on these glasses and is able to say that, look, this traffic is coming from these glasses. It requires so much bandwidth. It is tolerant for, it only has tolerance for low latency. And then we take that traffic and we prioritize it across the network so that the traffic that the shopper sees as they walk into a store and are looking at a piece of merchandise, that shopper can get real-time feedback on the price of what they're looking at, whether that merchandise is going to look good on them or not, and that will be prioritized over someone who might be watching Netflix on the same network. So this ability to do prioritization and quality of service for Gen AI applications is what Velo RAIN is all about. Now, before I get to Keith, I want to say that I'm really pleased to say that while I've been talking about the Gen AI applications and the smart glasses and everything, an application of Velo Cloud that we found through Nature Fresh Farms. Nature Fresh Farms is one of these really innovative providers of produce, and they not only make the products that you folks hopefully have had an opportunity to eat, but they also develop IT infrastructure that helps our entire community in making products much better. And these products are food, and they do it in a sustainable way. So I've been extremely pleased to have Keith Bradley, who is the VP of IT and Security that represents Nature Fresh Farm. So we're going to start off by showing a video, but first I'm going to invite Keith to come up here, and then we're going to see a video of Nature Fresh Farms, and then I'll have an interaction and a discussion with Keith about how he's using technology to advance produce and agriculture. Keith, thank you so much for being here, and let's roll the video.
Nature Fresh Farms, we are a 250-acre greenhouse growing bell peppers, tomatoes, cucumbers, and strawberries. The use of the Velo Cloud has allowed us to do AI compute at the edge. We've actually kind of started to grow out of a central AI machine, an AI language. We've been able to use 5G and even LTE to help us expand that, deploy our apps to the facility through a centralized edition to get that edge AI to compute, to understand what's going on at the edge, what devices are functioning, what are starting to give us issues, and do preventive maintenance to our equipment. One of the things that AI has allowed us to do is we're now able to recycle technology and use it in a new way.
All right, well, that was a very quick, short video, but Keith, first, please introduce yourself and tell us in a few words what Nature Fresh Farms is all about.
Hello, Nature Fresh Farms. My name is Keith Bradley. I'm the VP of IT for Nature Fresh Farms. What Nature Fresh Farms is we're actually a greenhouse. We're 250 acres enclosed in a building like this, just with a glass roof, growing bell peppers, tomatoes, and cucumbers. So everything we do is technology-based. Everything is IoT-based. Everything is trying to make that plant grow as quickly, as healthy, and as tasteful as we can, so when you get that product, it's ready for you. So our kind of journey started off where we had, you can see here now, this is one of our, so each range, there's 3 ranges here, that's 32 acres each. It's one of our home farms here now. What we did is we put one Velo Cloud out the edge, but we had multiple crops. There's multiple crops there. We're having a large language model for each one. We're dealing with what Sanjay said is bandwidth issue and response time, because we want to respond as quickly as we can to a change in the environment. We want to irrigate on time. We want to do all those things on time. So we started to actually divide it up. If you want to go to the next one now. So we started to divide it up. And this is the joy of the technology. What we did is we now put 3 Velo Clouds in, separating out the individual phases. So now they're individual now, and they're not as many large language models in there, and they're growing. So now we're starting to separate the crops out to where they are and letting that edge AI start to focus on just that plant, just those few language models. But now we've even learned to start to go into more detail of that. I'm going to go to the last slide there now, as we start to get to the point now, we're within one range now, we've separated it out. And that's where the VeloCloud has allowed us to do that, is we're able to put a device in, separate that network, aggregate the bandwidth, control the application, control the data movement. And exactly what Sanjay said, one device can't overload our network. One thing can't stop the AI from working, because if a plant doesn't get irrigated on time, it results in not optimal growing conditions. If it starts to rain outside and we don't close the vents before the rain hits, it actually does things we don't want, because we want to know exactly how much moisture they get. And that's the joy of having that reaction time that we need.
Right. So Keith, tell us about how you're doing the real-time data collection and how you're taking this data and applying it to grow different customized products. Like even in tomatoes or strawberries, you have different kinds of them.
Yep.
How are you using this kind of data inferencing and modeling to be able to grow?
Yep. So each location will have its own model now, its own specific model that's designed for it. So each VeloCloud is there at the edge, controlling that data, the language model for a single crop. So I know as a consumer, you see a pepper in the green in your store and you look at it, it's one pepper. That could actually be 8 to 10 different varieties for us that we're testing out to see which one is the right seed for it, what does the best testing. So those models are all slightly different. Just like each of us eat a different amount at lunch, the plants want to eat a different amount. So each language model has to be different. So we have to control those language models.
Now, how you're doing this, of course, in a sustainable way. So please tell us about how you're using VeloCloud and robust AI networking to be able to push the boundaries of sustainability.
Yeah. So one of the things we do, the neat thing that we do is we recycle every bit of water we can. Up to 80% of the water that we push out to that plant comes right back, and we push it right back out to the plant. So we don't lose water. We want to do it. And if you ever see a video of us, it is a fact, and there's water on it, the growers actually cringe, because that's not true. We inject the water right to the plants, so we know how much the plants absorbed, how much they don't absorb, and what nutrition they absorbed it, because we want to watch that in real time to make the next adjustment for the next feeding. We even will watch in real time the weight of a tomato vine to know, when do we irrigate, when is it time to turn off lights, when's the plant ready to go to sleep. We watch that because we want to optimize it. And that AI model is what helps us grow and become a predictive greenhouse to get what you need the best way.
That's awesome. Now, looking forward, what do you see as the opportunities to use AI, even up to, I know that at some point you even looked at glasses like these to help you in your crop growing, but also everything from that to AI robotics. So if you could take a few minutes and describe everything from using glasses of this type as well as to AI robotics.
It's actually a funny story. Our owner there now, probably going back 7 to 8 years now, I was trying to get the exact date that he sent the email to me. He's like, Keith, I really think we have to get some type of glasses or some type of camera system that will put a headset on his head and put a camera on his helmet, like, even before GoPro was a thing, and say, walk down the greenhouses and be able to interact with an expert grower, say in Holland or somewhere across the world, to get real-time data of how to fix plants, to be able to walk down the rows and do that. And it's funny when you talk about those glasses, is it's actually just starting to come to fruition that we could start to do that. But the concept of what he wanted to do and monitoring it and giving the AI has allowed us to start to look forward to that. So now we're starting to look at, how do we take visual data and make it more optimal? One of my hopes in the industry, and one of the biggest things I see, is we also employ about 3 to 8 million bees, depending on the type of year, to pollinate our flowers. And that's just a natural thing that we did. So we're actually going to look at, I think the industry will look at it, and I know we are, is when is the perfect time to pollinate a flower to get the best pepper? Because a bee will indiscriminately pollinate every flower it comes to. So how can we use AI to basically learn, take the data from the visual of the plants, take the growing medium that it knows, this is how it's grown for the last couple weeks. This is how much production we need coming up, because that predictive helps our sales know what they're going to do, and then pollinate the flower. Because we actually have groups of people in our BioScout division that basically look at it, and they will actually crimp off a flower if it's too much, or we'll cut them off. But the plant's already started to put energy into that. So we want to optimize every little bit of energy. Every AI model that we can help improve, do that. It's that. It's actually funny because I said that too, because they said, well, how are you going to pollinate them? I said, it's funny because before we had bees, that was the head grower's job, was basically to go out there and put a little bit of pollen in each one. So that's what we're kind of returning to that. We're kind of returning that where he probably knew how to do it, but the technology and the application wasn't there to be able to do it in our large scale. So it is an amazing thing to see how technology continues to change and how we continue to push ahead and do stuff. And there's stuff there that I've never thought. We now have robotics in the greenhouse picking the plants. Something I didn't think was ever going to happen in my lifetime 10, 15 years ago. I grew up as a farmer, never thought, but now they go down the rows and they pick the plants and they're done. Our smart farming was what we like to call us, and we're starting to get there with our applications. And like I said, our journey wouldn't have been able to get where we're at today without looking at how we handle the networking, how we handle the network architecture of the data we did. Because if I look at what we did and I left it the way it was, we would have had massive gaps. And I know it would have happened because somebody would have walked into my greenhouse with a pair of sunglasses, a pair of glasses like yours, and just knocked the whole network down and caused me all kinds of woes. But I now know we've kind of future-proofed ourselves.
Awesome. Thank you so much, Keith. Really appreciate
Thank you for having me.
explaining. So let me take the next 2 minutes and just wrap up what we've heard. One thing I can guarantee you, that this is the only session where we would have brought together smart glasses, strawberries, and bees all in one. So to wrap it up, really what we're looking at is a new class of applications that are coming in. These class of applications that are Gen AI based look very different from the applications that we're seeing today. The first one and the example of these glasses is that there's a lot more data being sent upstream. Even when you're at home and you are connected with your home network, it's almost always advertised as X amount of bandwidth, but that bandwidth is downstream. If you put a lot more bandwidth upstream, you're actually going to break the internet if there's enough of those applications like these glasses that are making use of the network. So that's the first point. The second is that the applications tend to be highly distributed, and those distributed applications need very low latency. So the example of the shopper, or in this case, maybe the bees or the strawberries that are growing, if you make a decision about how the bee should pollinate, about what the shopper should buy, and if you make that decision too late, then you've lost that moment when that decision should have been made. And so it's not optimal from a fiscal standpoint. So that's the second, is the latency. The third is simply the bandwidth. There's a lot more of these types of devices. This set of 2 cameras over here, 12 megapixels each, can generate an HD quality and above video. Now, if you just think that this is the fastest growing Ray-Ban product in the store out there, and just this one product becomes ubiquitous, is just going to have a tremendous impact on the networking infrastructure. So when you put all this together, what we've come up with is VeloRain, the robust AI networking architecture. And what Keith was talking about was the VeloCloud Edge. These are devices that if you're an enterprise customer, that you would purchase and you would put in various locations of your network. It could be retail locations, manufacturing locations, in Keith's case, the agricultural field. And all of these locations then would be linked up together with an intelligent network that is built for AI. So regardless of whether your Gen AI application comes in, it's Gemini based, or over here you look at ChatGPT, any one of these, your network would be ready for the Gen AI applications. And that's the point we're trying to make, which is that when the first wave of SaaS applications came in, the network needed to be upgraded. We believe that a similar move is afoot as the Gen AI applications come in, especially as all these discussions are happening here about agents running around talking to themselves. If the network is not ready to take care of that, the applications are not going to work. So I appreciate your attention for this time. I think there's about 3 minutes or so left for questions if anyone has any. Oh, yes.
Good question. So Meta is acutely aware of the problem in the network. And obviously, a lot of information processing locally, you're being sent down to the network. And if you look at Aria, which is the Meta's next generation platform, there's a processing unit on the side. You process a lot of information on the edge before you send them. Which means a lot of the traffic conditioning today will be all less than today. How do you answer that?
Yeah. So the question, if people didn't hear it, was that there are new classes of devices coming in, like the Meta Orion glasses that some of you may have seen at the Meta event that happened. A lot of the processing is happening on the glasses themselves before they are sent off. And this is just a specific example of what we see happening, which is compute at the edge. So edge compute with this specific example, or with examples of small language models that can be at the edge or be dispersed around the network. So this is not a different point in terms of what I'm trying to make, because when agents are running around, and whether the compute is at the edge or compute is not at the edge, even the edge compute has requirements of the network. In fact, if you look at the Orion glasses and the amount of traffic that they generate, it is actually more than what these glasses generate. And so when Orion is talking to the backend Meta LLMs, they require much lower latency. And now if you think that the response that needs to come back is composed of a number of agents that need to talk to one another, it has even a more acute requirement on what's going on the network. So we do believe in this model. We do believe that SLMs and edge compute and Orion and other types of devices are going to proliferate, including the types that Keith is going to think of or planning on deploying in his farms. And all of these are going to require this sort of agentic peer-to-peer interaction that is not available today. You had a question for?
Sorry. Yeah. By the way, precision farming is amazing, right? Like, when you say you separate the three large language models in the same warehouse, let's say manufacturing, farming, how do they get better? How do they know the model can feedback loops? How do the model get better? How active? How do you measure?
Yeah. So the question is, how do we update our model and how do we get better? So the one thing that we do is, yes, at the edge, we keep the large language model there. It does compute. And each night, it actually will upload in a controlled fashion to our main headquarters. And then what it'll do is, it's actually kind of neat. And in the pictures, we only had one range, but we'll have multiple ranges. So we have peppers in Canada. We also have peppers in Ohio. We have our history of data of what we did. And it starts to pull all that together, and then it republishes itself back out to update that large language model. We usually do it weekly to kind of look back at the past of what's happening, because crops are seasonal, but diseases are almost generational, I like to say. And so we'll start to see issues from past come back, creep back in, that happened 5 to 7 years ago. That's one of the reasons why we were so lucky with our data, is we've been keeping data of how we've grown, how much is picked, how much is done for 20 years. And it's very clean. It's not the garbage in, garbage out you get, but it's a very clean thing. So our growers have lived by that data. They've just went from sitting on a computer now, punching it in, to now letting the AI more choose it. So we use all the different crop data we can.
You just shared this data with another corporation, like open source, or is this proprietary?
It's very proprietary. It's a hard one to get out of. I'll be true with you. Like, it's just one of those things that's what we use to grow. And, we are looking at ways to help share it and organize it within the community, but it's just a matter of how to do it all.
I think if you talk to my
Sure.
we're not going to be great for lunch, so you can compliment that as many questions as you want, as long as you talk.
Okay. Are there any more questions? Yes. Go ahead.
I actually had a question for Keith.
Yep.
Aside from like the cameras for visual input and stuff like that, is there any other hardware that you guys use for data collection, and some of the other things like
We collect everything from light, refractive light from the sun, so what reflects off the ground and through the clouds. It's different wave levels. We also have artificial lighting, so we'll record how much light we're putting into that. Another example of what we record is we actually use natural gas to heat our greenhouse. Through water, we heat through the conduit. Natural gas produces CO2. We reclaim as much of that as we can, and we funnel that to the plant as a natural stimulant for them. You name it, we probably record it in some way or shape. We basically, how I look back, and I did a study years ago with it, we have about 1.8 million plants, and each plant generates up to, I like to say now, about 5 gigs of data a week for what it generates. A lot of it's transactional, like just what's happening, but we monitor everything. And that's where we could start to build that model because we had so much data. Yep.
So when you were like, making an evaluation of like which providers to go with, I mean, there are like other cloud providers too, right? Like Google, Amazon. Like, what made you decide to go with Bell?
The one reason that we went with them, it's a neat proof of concept story of what we did. Basically, originally we were using it just for interconnection between our farm hubs, just to start to do it. This is before AI was even a discussion. And I basically called up on a Friday morning, and the equipment arrived Thursday afternoon, got the tech on the phone. He's like, yep, so we can start setting things up. And I said, well, plans have changed. We're moving offices. I need this working in the next 2 hours. And we deployed it from there and went from there. The biggest hindrance of why we don't rely on clouds is we are in the middle of nowhere sometimes. So we've really had to find a way to do it on our own infrastructure. So our cloud presence, other than Office 365 and a few things like that, is actually pretty limited. We really like to focus on putting it on-prem. And then the next big fear is you have this huge greenhouse being controlled. What happens the moment the internet goes out? What happens when the moment the internet starts to lag? How does an Azure thing affect us and just knock everything down? So we tried to keep it as close as we can so we can use it. Because in the instance we had where we had different ranges, we can go without internet for weeks and still be using the AI because it's locally there.
I have another, just one more question.
Yeah.
You say you use large language models. What do you use large language models for?
For everything. So we do inferencing on the leaves, the growth, climate, all that to determine when to irrigate. So a grower can put in saying, I want to irrigate 5 times today. I want to irrigate X amount, but I only want to do it if it's sunny out. So then it'll now pull in and it'll say, okay, what's the weather going to look like for today? When do I actually do this? And then it'll actually give the grower suggestions saying, hey, we found when you do this much irrigation, it's not quite what you want. Then the next joy of life that the growers did, and where we originally started with our AI journey, is now the grower more just sits at home and goes, oh yeah, it's starting to do this now. The model has now changed it because it's looked at how the leaves are wilting, if they've absorbed the irrigation of the plants. It takes all that data into itself. Yeah, like we. Yeah, so it actually makes a predictive decision to help make it as optimized as possible. That was our original goal, was that to turn it to a reactive and to allow our growers to be able to be back out into the greenhouse. Before they were just sitting in front of a computer, changing the numbers. Now they can actually let the AI run that model, do what they do, and be out in the greenhouse looking at the plants.
Sorry, those models are prepared to fine-tune to your use case.
Yeah.
And what's the foundational model that's well based on?
The foundational?
Yeah, like you use the LLM, right?
Yeah.
You use one of the big ones, or you actually.
We actually built it. This has been like a 4 or 5 year project. Like we really built. Yeah, we started actually building it ourselves because there was nothing out there really. Like you think of what there is now, it's just starting to get there. But to say, can you find an LLM that helps you grow your plants at home? Really? Yeah, it's just that uniqueness of our industry. Pardon? Yeah, it can go. We can fit in all kinds of buckets. I'd like to say over the years.
One last question.
You mentioned 5G. Are you using private networks for that? Is that on a public network? Because you mentioned some sites are remote, and then the edge compute. Do you have that on each of the classes, the greenhouses? Sorry.
Yep. So 5G, yep, we have been using that both as not only a primary internet feed, but as a backup. We find is that Wi-Fi does not work well in the greenhouse. The humidity of the plants doesn't work well. 5G does work better. We haven't gone to the private 5G yet. Something we've discussed, and we just haven't got there yet to do it. There's only so much technology we can implement in a day. The other thing, what was your other question? Sorry. Oh yeah. So that's the neat thing is it actually so each edge kind of keeps changing each season. So as we change the products and within a plant phase, it changes the edges that we're going to have there. So it kind of gets redefined each season, sometimes multiple times within a season, because we'll have peppers in a range one season, and then we might put cucumbers in the next year. So it changes. And what we're more trying to do is to more distinguish just the individual varieties now within that classification too. So it's growing, and I continue doing more and more at the edge and segregating it out again and again and again.
Thank you. Thanks very much for your attention and attending, and thanks again, Keith.
Thank you. Anytime.